Hey there, everyone, and welcome to the special JS drop. I'm here today with Jesus, who is on the This team, one of our engineers here at This, and I'm so excited to go a little bit deeper into fun AI things that we've been exploring. My name's Tracy. You can follow me on Twitter at LadyLeet or on LinkedIn at Tracy S. Lee. And Jesus, where do we find you?
You can find me on Twitter. You can find me at Jesus44997, or you can find me with the same name in GitHub as well.
Nice. Amazing. Okay, I'm so excited again. Tell us a little bit about what we're doing today.
So we're going to show today how to integrate Llama or Llama 3.1 into your application. Llama is going to run locally, which is the cool part. I mean, everything's going to be super easy. We're going to use the SDK from Versal that is called AI to use our model really easily in a Next.js application, although you can use whatever framework would you like to. And we are, to make this a little bit more interesting, instead of just creating a chatbot, we're going to do a kind of a AI voice assistant where we're going to use 3 different models. We're going to record a voice and transform that audio into text thanks to the Whisper model of OpenAI. And then we're going to take that text that we transform and we're going to pass it through our Llama 3.1 model. It's going to understand this text and it's going to give us a response back. And that response, we're going to send it back to the user, but by a voice. And we're going to do this by another model from OpenAI, which is called EDS.
This program is presented by This.Labs, a framework-agnostic consulting firm helping enterprises realize their technical goals through staff augmentation, consulting, project management, on-demand subject experts, training, and other professional services. Find out more at This.Labs.com.
Oh my gosh, that's so many exciting things to learn today. So let's go ahead and get started.
Yeah.
All right, I'm going to go ahead and share your screen.
All righty.
So for the people who don't know, tell us a little bit about Llama.
So
Llama.
Llama is a new model that just came out. Well, Llama has been out for a while now, but the new version 3.1 just came out really not so long ago, and it's a Facebook model, and it is open source. You can actually, if you go to Hugging Face, where all the open source models are, you can click on here and you can find it really easily. Well, not Facebook, Meta. I'm not used to it yet. And you can find it here as an open source model. And you can download it and you can train it. You can do some RAG, fine tuning to it. And there's some documentation here. There's this thing called Llama, which is a little tool that helps us to run Llama really easily and really straightforward in our machine locally. So the first step that we would like to do in this demo is to go to ollama.com and click here on download, choose the operating OS of your preference, and click here on download. I already did that, and if you do that, you will see
Can you make your screen a little bit bigger, like the text a little bit bigger?
Yes, of course. There you go.
Thank you.
Is this better? Yeah, no worries. So yeah, you click on here, you click on downloading the model, and here in the console, now if you follow the steps of the little app installer, you're not gonna have this little command here. And there's a lot of models in which you can choose. If you click here on all models, here's the list of all the models that you can use with Llama. I downloaded Llama 3.1, which is the newest one, but you could use Feed3, which is also a great one to start with. So if you choose your model, download Llama, you can run that model locally really easily by running this little command, which is Llama run and the model name, and you will see here that it is now running. So if we ask like a little prompt here, and we keep asking that, he's there, getting a little bit mad with us because we're asking everything.
That's so cool.
Yeah,
I've
right.
actually never seen like a I don't want to call it GPT. What do you call it? Like an LLM responding to you through command line. So that's amazing. That's
Yeah,
really amazing.
And I think the best part is that it's so straightforward. You just click 2 times in a button, and there you have it. Just run a command, and you can start using it. So it's really cool. So now, how do we use this model in our Next.js app? So let's use Versal AI SDK. This is a new SDK that Versal just released, and it has been for a while, but not as long. It's kind of new, and they introduced the way to use a way to use Llama with this SDK. It's really straightforward, as you can see here. We're gonna use a different package though that makes it even easier. We're gonna use AI Llama provider. So it is a community library, and it's really, really cool. So it helps us to just run our Llama locally. And
this is still Vercel's AI SDK for those of
yeah,
you
this is still, yeah, exactly. This is like an extension of the SDK basically, and it's gonna help us to run Llama and with the model that we downloaded in our application. Also, as I explained before, we're gonna use 2 different models, different than this one. We're gonna use Whisper from OpenAI to transform our speech into text. This is not gonna run locally. We're gonna use OpenAI servers, so we need an OpenAI a key for this to run. So we're gonna use Whisper with our Node.js SDK, and we're also gonna use TTS model to transform the text into speech to have the response out loud in a voice to the user. They have different voices for us. It's kind of cool. Like, it's really,
Well, we
really cool.
can't hear anything specifically, but that is really cool.
Oh,
And so, sorry, just going through really quickly again. So you're looking at OpenAI and you're looking at the different models. Is that right? What we
yes.
would call them?
So OpenAI has different models, and they have Whisper, for example. And Whisper is the one that is going to be the one in charge of transforming our speech into text. And then they have a different model, which is called TTS. And TTS is the one that does the opposite. Basically, they're going to transform the text into speech. And we just need those 2 models from OpenAI.
For OpenAI, the model that we are most used to is GPT-4o. Got it.
Yeah. That's one of their models. It's the most popular one, but they have also really, really cool other models like these 2. And let's set them out because they're really cool. I want to share it. I'm excited. So with all that introduction, let's go ahead and create a Next.js application. Again, you could use another framework of your preference, but I went ahead and started with Next.js. So just
okay. And sorry, I'm going to be annoying and ask again. Can you just make the text bigger?
Yeah. Oh, I thought that. Yeah, there you go. I'm sorry for that.
That's better. No, it's okay. It's just I'm on a really big screen right now.
Oh.
And I'm sure other people aren't. So maybe a little bit bigger.
A little bit. Yeah. Maybe like
Thank
that.
you. Yeah, that's better. Thank you.
Cool. So let's go ahead and just run this little command here and choose your preferences here. These are following prompts that the terminal is going to ask you. I went for everything here. I went for TypeScript, Slant, Tailwind, everything. I just press enter, and you can do the same thing.
So just basic next app setting up.
Yeah, exactly. That's right. So we need to install our dependencies, which is our SDKs mostly. And if I go here, I already installed them. So they're going to be AI, which is going to be our Versal SDK. Llama AI provider is going to be the library that I showed you before that is going to help us to integrate Llama in our application. That's going to run locally. We need OpenAI as well, which is the OpenAI SDK for Node.js. This is the one that is going to help us to use Whisper and the TTS models. So just go to the console, and I'm using npm, but again, you can use any package managers of your preference and just add all the packages. I'm gonna run this one more time in case I need, I missed something. I also install CLSX for the styling. You don't need to do that. I'm just, I just like it.
So if you just install OpenAI as a dependency, then you can use any of their models, like the
Yes.
TTS and everything like that. Okay, that's nice.
Yes, that's really cool. Yeah. This is everything that you need, OpenAI. So we, as I said before, we need a OpenAI API key because we're going to use their servers. This is not Whisper and TTS are not going to run locally. So we need their servers. So we need an API key. So I put a EMD example here. I'm not going to show actually my actual key, but you just replace it with yours. And once that's set up, we can start coding. We can start with an actual thing. So let's go to the page.tsx. We don't need any of these actually. So let's delete all of this. And let's create a
That was just the
different-
boilerplate for the next app, right?
Yeah, this is just boilerplate. We don't need that. It is the screen good, or do I need to zoom in a little bit?
Maybe one more.
All right, let me do that really quick. Let me do 5%. Is it better now?
I think like 150 would probably be better.
150? All right, sure. There you go.
That's
All right.
good. Thank you.
No worries. So yeah, so here's the thing. We're gonna record our audio, right? So we need to use browser features. So we need to use client-side features. So we cannot use, we cannot start recording our voice in a server component because we don't have browser features. So in order to not make our entire app the client side, we could just go to the top of the file and use client, but that will make the whole tree client side, and we don't want that, to be honest. We want to enhance our page progressively by integrating client components into server components as we would like to. So let's go ahead and create a new directory here, and let's call it components, and let's create our new how should we call this? Let's call it audio component, just like that. Audio recorder .tsx. Again, this is gonna be a client component because we need to use client features. So let's start with that function audio recorder. Oops.
Well, you called the component auto recorder. I don't think you care.
Yeah. What? Okay. Audio. Thank you. Good catch. So let's do some little thing here. Just let's create a little button. I don't know. Let's do just a single button, and let's import CLX to make it easier. And let's add some tailwind. Oh, there you go. What is this? Interesting. Let's go with that. Yeah, let's go with that. I think we don't have.
Thanks, GitHub Copilot.
Thank you. Let's see if center the button in the middle of the screen. See what you can do. Oh, that's good. I like that. Okay, cool. So let's click on here on start recording. I think that's a good start. And let's import our new component here. Audio free. Oh, I'm not importing this. Export default function. Well, let's do that now. Record. There you go. Oh,
Typo.
Audio
recorder is typoed.
Yeah. Thank you. And there you go. Nice. Now let's go to localhost and see if that's there. There you go. That's actually a really nice looking button. Thank you, Copilot. Now let's do our client logic first. I'm gonna create a hook. Let's create a hook for this. Let's do it here. Hooks. In this hook, we're gonna have all the logic for recording or audio. So let's call this audio. Use record voice to this 6. Yeah, and then let's do a function. Use record voice, and yeah. So we need a couple of states here. We need to pick a way to record. So we're gonna stream. We're gonna speak to the mic, and we're gonna stream our voice into the client. So we need to take those chunks of information, inserting it in a reference, right? In order to then send them to the backend, to the server side. So let's do that. Let's create a reference. Let's call these. It's gonna be chunks of data. So let's call it chunks. Audio chunks. That seems good. These are gonna be blob objects. Come on, there you go. We also need oh, hold on. There's something that I wish to have here. I also install Preacher. But it's not recognizing my config. Well, doesn't matter. It's just that I wanted that formatted nicely. So, okay, so we have our audio chunks. We also need a MediaRecorder. That's nice. So we are going to put that in a state. Oh, we also need a flag for knowing if we're recording or not. That's also good. We also need the MediaRecorder. Let's put that in a state, MediaRecorder, send your recorder. So MediaRecorder is a browser API that help us to record any audio or video coming from a media device from the browser. So that's going to be really helpful for us. And I think that's about it.
And what's audio chunks?
So audio chunks is going to be, so when we speak to the mic, we're going to send chunks of information. We're going to get that chunks of information, and we're going to store in this array of chunks, which is going to have all our audio data, basically.
And like, how do you know that? Is that through reading OpenAI's documentation, or is that through reading?
No, well, this is OpenAI. The docs they suggest to send a audio file. So basically, if you have, let's say, you have a video or I don't know, a YouTube video that you have in there, and you can put that file into the SDK, and they're going to transform the audio of that video, for example, into text. So this is just plain JavaScript things that we need to do in order to record our voice via the browser. So the SDK Whisper, how it works is that we need to send it a file, and we're going to see that in a few seconds. But basically, we're going to take all these chunks, we're going to transform it in a base64, and we're going to create a buffer. That buffer, we're going to use a specific function from OpenAI that is called isFile, that is going to transform that buffer into a file in a specific name with a path that we're going to specify, and we're gonna then send that to the SDK. So now Whisper is gonna understand this as as a file of audio. That's what's gonna happen. I know that's kind of weird what I said, but you will see in a second. It's gonna make sense in a second after we build this. So let's go ahead and create that method, which is actually what I want. I think Copilot knows what we're building here. So we can use, there you go. We also can use this. We can use the Navigator API. The Navigator API, it is from the browser, and it tells us basically information about the environment of the user browser. So if we use the Navigator, we can check if the user has media devices. So, it's complaining here. President if it has any type. How do I specify what are you? You are a navigator. Interesting that you cannot. Well, let's do this. Let's do cons navigator. No, let's do it here. Ref. Let's do navigator as navigator. Let's put it. Let's put it here. So, all right, so this is complaining still. If it has any type. You would? You not? This is interesting. Why do you have simplicity any type? If I use it from here, if you understand me here, but not there. Interesting. Let me do a quick test. Let's return all the things that we need. We don't need to return that. We don't need to return any of that. So let's call this const use. Oh, they're not exporting. I always forget to export this. We'll export that. And we want this recording. So maybe we could pass here the navigator as an option here, and pass it over. And then we call creator function to start recording. Now we can also use it. Okay, now it works. So if we don't have media devices available, well, the user doesn't have a media device available, we would like to console log this as an error, because we cannot then record a voice, and we will just return. All right. So with the same navigator, well, Copilot is spoiling everything, but basically we can create an stream with this same API. We can use the navigator to get the user media devices. We can choose only to get the audio, and we can create a stream. We can open a stream between the, this is async, a stream between the user and the mic. And we need a way to record what the user is going to talk to the mic. So we're going to use now our MediaRecorder API. and we're gonna send as a parameter the stream. So now we will be able to record whatever we're saying. Well, we need to actually start it. Let's not stream, but start. And we can specify when to do it. Let's do it immediately. And yeah, so any questions? Are you guys following for now?
Yes, we're ready to see it.
Okay, cool. There's one thing to be done though. So remember that we created these audio chunks. We are recording what we're saying, but we're not like storing that data anywhere. So we need to do that. Let's create an use effect, and that's actually what I want. Oh my god, yes. So if we have the MediaRecorder, which remember we are setting here. Whoops, sorry, caps. We are starting here. We're setting up here. We're creating the new instance. So if we have that, and if we have data available, we want to get those chunks, those data, and push it to our audio chunks. And also, if the user clicks on stop, which they cannot right now because there's not a method for that. But if they click on stop, we are gonna create, with all those chunks, we're gonna create a blob with this audio, and we are gonna, well, actually, we don't want this. We don't need that. So we want the chunks there. This is actually something helpful. Because we will need to then send this to the backend. Okay, so we now have the blob, and we don't have a way to stop the audio recording. So let's do that method now. Function stop recording. Yep. And if we have a MediaRecorder, just stop that, and we want to set its recording to false. And yep, that's it. So let's stop recording. So let's return all methods, our methods to the client. Let's see if everything's fine. So this is a function. Just to keep consistency, I'm gonna create a arrow function here. There you go. Now in here, it will take or stop recording, start recording, and we can change this to is recording, then do that. Oh, stop recording. If not, start recording. Cool. So we want also to call this method. Click. Let's create a function here. Handle click. So if recording is stop recording, I'll also start recording. Yeah, that makes sense. Then it's recording. Oops. Handle click. And this is a promise. There you go. So now, if we go to, I have an error somewhere. I missed a bracket here. There you go. Okay. Now, if we go to here, if I click here, it is not changing.
Well, maybe because it's not recording.
Maybe. Let's see our console. Maybe it's not picking up my mic. Let's see here. Hello. Let me refresh just to make sure. Interesting. Let's see the console. So, navigator is not defined. That's interesting. Huh. Why are you not defined? Well, let's do that to see if we get the error. Huh. Okay, let's see the looks really quick of Navigator. Because if I remember correctly, we just versus objects. Yeah. Okay. You're getting it right. Let me check if I say like that and we just delete that. And if we access from the hook, we wait a bit. Will that work? Okay. It's retrieved from the server.
Did that error pop up when you click the button though? It seems like
Yeah.
I think the error was there previously. I don't think the start recording button's actually.
Oh, I'm sorry. I hear you a little bit laggy. I don't know if it's me.
No worries.
So yeah, I don't see the error anymore. So that's interesting.
I don't think the error was from the button.
Right? Yeah, me neither. Let's see. Let's restart the server. Let's see if we get something now. Yeah, so it's just from the server. Okay. So let's go back here. Let's post this native. And let's go here. This looks okay. Huh. What's going on? Okay, let me check my little notes here. See what's might be failing. Oh, I see what. No, wait, that's fine. That's totally fine. It's pretty sure that is the hook. Oh, hold up. Getting installed.
What are the errors telling you?
There's extra attributes
Extra
on the
attributes
server.
on the server.
Yeah. Yeah. Zoom that in. Right. So the issue was that we were actually recording, but I forgot to set the state as true when we were recording, so the button wasn't changing. So now we are recording our voice. We're not seeing anything yet, but yeah, it should be working. We should get a blob here. Actually, if we go ahead and we let's console log the outer chunks, we should see something. Oh, there you go. A lot of blobs. Hello, hello, hello. And there you go. That's all or voice data. Nice. So let's take that blob and let's not create a URL. Let's create a new method that is we're gonna send this as base64, and we're gonna call our backend that is gonna understand this this thing. So let's do that. Let's create a method called get response, serious response. Like that, we're gonna receive well, we don't actually need to receive anything because we have our data here in our blob. Trying to see. Okay, let's go ahead and create our API. Let's go with that first. Let's go. Let's create our new route. Let's call it chat. It's not our file, but a directory. Let's call it chat, and let's call it this route.ts. We're gonna add that, and this is gonna be a post. We're gonna get request, and we're gonna add. Well, we need to use our OpenAI, so let's go ahead and create our instance of OpenAI here. So we need const OpenAI to AI. Nope, that's not what I want. Let's OpenAI. Let's create a helper function for this, actually, to make it a little bit cleaner. Directory, let's call it utils, and let's go ahead get OpenAI. We're gonna add that. We need to factor this to yes, and this is gonna be a quick functional helper to get our OpenAI instance, OpenAI, and const OpenAI, not like you const OpenAI equals new OpenAI, and we need the IP key, which we defined on the EMB file. We're going to import that from OpenAI, and we're just going to return that. We're going to export this function, and we are going to go back to the route, and here we just do get const OpenAI equals get OpenAI from the URL file. Good. Now, actually, we don't need that in the route. Now we need to use also Llama. So as I said before, we're going to use all Llama, and we installed this library that was called Llama AI Provider, which is going to help us to run Llama really easily. So let's import that, and let's create our instance here. And if I remember correctly, it's going to be create Llama, and we can set in here a couple of options. So if you go to a terminal, not here, if you go to the terminal, you could run your Llama application just by doing this, Llama serve. Oops. Oh, well, it's already listening. I have it ready, running already. I don't think that this is the one. I think it's running in a different terminal that I have opened. Yeah, but if you run this command, it's gonna open a port that is gonna basically run Llama. And your Llama by default uses this URL. You can change that, and in case that you change that, or let's say that you have your model of Llama in a server in the cloud, you can change that here. There's a property here that you could change the whatever you have your server. As I'm running it locally, I don't need to add any option here. Actually, I'm not adding any new option. I just call this like that because by default, Llama knows that it's going to use that port for us. So, all right, let's go ahead, and we should get from the request, we should get, which by the way, this is request. We should get our audio, which I said before that we are going to get this as a base64. So we would like to transform that into audio buffer. And if you remember correctly, let me do that first. I'm going to explain something really quick here. Yes, there you go. We're just creating a new buffer. We're passing in our audio, which is a base64, and we are just specifying that this is a base64. So if you remember correctly, I said that in order to use Whisper SDK, we need to send in an audio file. So we don't have a file. We're just, streaming this data. So let's go ahead and use, let's call this audio file. Let's use isFile method from OpenAI. And what this is going to do, let's import isFile from, oops, it is not isFile, it is toFile actually, yes. So what this is going to do is it is going to transform our audio buffer into a file-like, and we could use that value for the SDK. So let's do that really quick. We need to specify the format of this audio. I'm going to go ahead and just choose MP3. And now with this, I'm cool. Let me do a try catch here, by the way, just to be sure that we don't have any errors in the feature. Just something quick like that, and let's return next response error. So now let's do a JSON better, and converting audio instead of 500. There you go. So just in case we have an error, and actually just include more information there. So now we have our audio file in here that we're gonna send, and we would like to use our Whisper to get, the text of that audio. So let's do that. Let's do a transcription. Now let's do await OpenAI dot. We want to use audio, yes. Now let's do transcriptions, create. We choose the model here, it's gonna be Whisper. We specify the response format, we want text. And this is what I'm looking for. Are you G8? What are you expecting here? So file. Okay, so the file is going to be our audio file that we just sent. Now, in theory, after doing that, Whisper is going to take our audio file and it's going to transcribe it into text. So we're going to have our audio transform into text, and we could pass that into Llama so it can understand it. So for that, we're going to use, let's call this text. we're going to use generate text from AI. It is a really awesome method that's helped us to generate, use a model to generate text, to understand text and generate a response for us. We need to specify here that we want to use our Llama model. For that, we are going to use our Llama instance, and we are going to specify the model that we want. In this case, it's going to be Llama 3.1. We can also add in here, like, if we're, explaining what the system is to it, like, hey, you know a lot about, oh my God, about video games. And now they have this mindset that they are an agent that they know a lot about video games. And now we need the prompt, which is going to be our transcription.text, right? And that's it. Now, with these, they're going to understand the text, and they're going to give us a response back. Actually, let's call this response, because it makes more sense. And then with that response, we want to send back to the user, but by a voice. And again, we're going to use another different model, voice response, which is we're gonna use again text to speech. I think actually we need this only speech, could be. Audio. That speech. There we go. Cool. Now, the same thing. We specify the model. That's another model that maybe that's another way to call it, but it is called TTS. And we just send the text that we wanted to transform, and the voice. We need to select the voice that this thing is going to use. They have a few that we can choose.
Is that is it typoed? Is it supposed to say response or is it response?
Oh, that's a typo. Yeah, that's a typo. Good catch. I'm so bad at this. Okay, there you go. So now we can choose.
I mean, it wasn't a typo if it was, originally hooked in.
That's true. That's true. So now let's choose whichever voice we like. I love Onyx. I don't know. It feels super cool. So let's use that one. And this is complaining about something. What are you complaining about? Oh, it is not text. What is it? Oh, it might be prompt, maybe? Prompt? No. Okay, let's see. What are you expecting? You're expecting input. Okay. I don't know why they change this all the time. All right. Oh, maybe not. Okay, because this will be something weird. Yeah, text result. Okay, so it is expecting a different. Okay, response. Can we specify? Well, no. Sure. What we need to fix this. Oh, because it is. Hold on. Let me check what this thing is returning exactly. Because maybe we have an object for sure, but prompt generate text, call settings and prompt. What do you have? Oh, there you go. I need to. Response is inside here. Let's call this response. There you go. Now it's working. Cool. Now we need to stream back. We're gonna get like this voice response is gonna be a voice file, but we need to stream that back to the client. We could create an audio file and we could reference that in the client and reproduce it. But will be more cooler if we just stream that back to the client. So let's do that. So let's create a response, and yes, let's return the body, and let's specify what this is in the headers. Yes, this is going to be an audio, and no, that's not what we want to say. Yes, we want to say in the headers that this is a transfer encoding and that it's going to be chunked to ensure that this is going to be streamed back to the client. So there you go. That's everything that we need on the server side. Any questions in here?
No, I'm ready to see it in action.
All right. Well, we still need a couple things to do. It is not ready yet. So now we build this method. We need to call this API that we just created. We need to send the blob in base64, and we need to then receive it and reproduce it. So first off, something that I noticed here is that we are not resetting audio chunks. Oh my god, audio chunks.ref, that current, equals empty. So I'm emptying the audio chunks because if the user clicks on stop, we want that chunks to be empty. So when they click on record one more time, we're gonna add the new data in. So now let's call our get response here. Yes, get response. And we're gonna send our audio blob. And here we're gonna specify audio blob. This is gonna be a blob. And yeah, so again, we need to call the endpoint that we created. We need to transform this into base64 before that, because it is expecting not a blob but a base64. For that, let's create a quick helper function here. Function transform blob to base60. Well, let me see if that's what I want.
Typo.
Oh,
in the function name.
Transform. Oh my. Okay. Thank you. One more time. So yeah, I think this is nailed. This is what we want. We want to transform the blob into base64. I think that's about right. Let's test it out. So let's get our audio base64. Yep, just like that. And this is a promise. So let's create it as this. And there you go. And now let's call our endpoint. First, I'm gonna just add a new loader indicator here to know when the service side is doing stuff. So let's go and we'll try catch. The error. Also log error. And let's set loading as true. And here finally, let's set it as false. False. Okay. So let's use the fetch from Next.js. Thank you, GPT. That's actually everything that I wanted. So we created this endpoint. This what we created here. We call it chat. We're sending the audio base64 as a JSON, and we're specifying that in here. Now, let's do a quick check if response is not okay. Let's throw this. You never know. I don't know if I nail it at the first try. So we need to get this response, right? And this is going to be streamed back to us. So we're going to use something that is called audio context API. So Audio Context API is going to help us to store this streaming data, right, inside what is called a buffer source. And when it's ready, we can then start it. And with the audio context, we can also connect, basically say where this audio is going to be coming out from. We can choose the device that the user is using. If they're using a headphone, then it's going to play in the headphones, for example. So we want that. We also need a reader. We need a reader to read the stream that is coming from our backend. So we're going to get it from the response body, and we're going to say get reader. So now we're going to create this reader that is going to, get the by us. I'm also going to use the audio context to create a source. As I'm explaining, this source is going to be where our audio is going to be stored. It's going to be the buffer source. And let's create 2 more variables. It's going to be kind of the same as the chunks reference that we have, but this time we don't need it. We don't need a reference because we are now streaming back the chunks of audio. So we need to do basically the same thing here. I'm going to create a loop. Well, I need a flag. Data is data streamed. Let's call this as false. So while this is false, let's add that. Let's use our reader to get that value. Reader. Well, let's add a if no reader for some reason. Let's throw get a response. So we don't need this extra check there. And so our reader, when we tell it to read or stream, it's going to return us back the value, and also it's going to tell us when it's done. So if it is done, we want to stop the loop. If it is not, if we have value, which is basically going to be uint a array, which is basically a row byte. We're going to push that into the chunks. Good. By the way, let me specify that in here. This is going to be u array because it's going to be just binary data that we're going to get. Good. Now, when we have all the chunks, we need to put it inside a single array. We need that because we want to store it in the buffer just as a single audio. So let's do that. Audio buffer. And let's use new. Let's use a array method to create a new one, and we can do a map and then a filter. Let's do a reduce here. I think it's gonna be quicker. Not to audio chunks. That's really, oh my god, reduce. So we're gonna have here we're gonna have for value, and we want concat. I don't think that's gonna work. Concat. No, we don't want that.
That's spelled wrong.
Reduce is the spelled wrong?
No, the concat was spelled wrong.
Oh, okay. All good. I'm trying to think quickly how to make this fast. So reduce, again, we have the account and we have the value. Again, this should be really straightforward. We're just trying to merge everything into one. I just want to create a one-liner. And then we have the accumulate, of course, and we want to create a new array from get value. And I think that's it. This is going to start as an empty array. Why are you complaining? Argument number. Well, these are bytes, so these are basically numbers. Say number. Okay. So how do I do? Account. Oh, I forgot to. No, not the push. Concat. And this is going to be a number array. Unit array. Add chunks. Reduce account value. Virtual account. Concat. Accumulate, not account. I don't know why I keep saying that. And array from value. Oh, I think it is because okay. This number. Okay, there you go. I missed the comma. So, okay, let me go through it one more time. So we're getting the chunks. We're going to reduce. We're going to accumulate. It's going to be an empty array of numbers because we're talking about bytes here. We're going to get every chunk, which is going to be a uint array, and we're going to put all of them into a single array with the concat method. All right, finally, we're almost there. Now let's. We have now this audio buffer, but we need to decode it in order to use our browser API. If we don't decode it, it's not going to understand it. So let's do that. Actually, let's use our source that we created before. This is where our audio is going to be. All right, it's going to be stored. Yes, that's exactly what I want. And we need to connect the destination. As I said before, this is going to be the headphones or speakers, whatever this audio is going to be played out. And I think that's it. Source start. We start it. And we start to play it. And I think that's it. I think that's the code. Let's test it out. So
no errors. No errors.
Please. Okay, let's see. Hello, how are you? Oh, I forgot to use my loading state. Now we don't know if it is loading or not. Oh, we got errors. Error getting response. Okay, let's see. Oh no. So the audio file could not be decoded or its format is not supported. Okay. The audio file could not be decoded or its format is not supported. Let's see. Let's see what happened. So you failed. So we're getting the buffer here. Let's do a different extension. Let's see if that fixes it. I don't know if map allow it. Okay, global file like. Well, oh, there you go. So they accept WAF, not MAF. Okay. How many?
Looks like they accepted MP3 as well, right?
Yeah, that's true. Is it right?
Mm-hmm.
MP3, yeah, so this is not the issue. So it is meaning we get the buffer, we get the audio from the response. And we get the which programmed. Let me do this 1 second and see if, because it is maybe it is expecting audio transcription create. Are we sending the right audio 64? Maybe this time for me not working. Okay, let's try that one more time. Let's refresh. Hello, hello, this is a test. Yeah, so probably data frame cannot be decoded. And we're getting this from, okay. Okay, let's go ahead one more time. Probably this is not being transformed correctly. Let me create a new method for this. Let me check if this is actually correct. So we get a new file reader. Oh, it's doing all. We don't want that. We want all load end. Maybe that's. And this is not actually what we want. We want a reader. Result. Yes, the string. Split it. I think this, I don't remember how to do this, but I think that's the way. I think that's the way. Let's try one more time. Hello, this is a test. No errors. Eat. Did you hear that? It actually responded back.
Did it? No, I didn't actually hear it.
No, it's not here. My audio is not getting through.
But it actually worked.
Yeah, it worked. But it got back to me in a different language, and I don't know why. Let me. Can I specify the language?
Yeah, it looks like you did. Language English.
Oh no, this is not a
It
one.
auto-corrected for you. Oh, yes.
Let's see if we model input. How do I specify? We might need to go back to the.
Well, let's
quickly.
prove that it actually works.
Okay.
So how do we like, can we use a different audio output from your mic or from your computer to hear it?
Do you mean like
So that we can hear? I think if you like don't use your headphones and you use something else.
Oh, okay.
Like
So I will need to go. Oh, I know what to do. Oh, I just disconnected that. Can you hear me still?
Yes.
Oh no. Hold up. Let me try. Go to settings, audio. Let's use the speakers. Okay. Let's see now. Well, I'm gonna check how to change the language later, but let's try with a different language for now. Where is it? Okay. Hello. So, do you know about video games? That reminds me to, while we wait.
Did it respond?
No, not yet. It's loading. It's kind of.
That's cool. I can hear it.
You can hear it? Really cool,
Yeah.
huh?
Yeah.
Nice.
That's amazing.
Yeah, right. Let's improve this a little bit, and let's
Well, we're short on time, so maybe we should do a quick summary really quickly on kind of what happened and walk through, and maybe how do we get a 60-second summary?
Right. Let me put back my audio really quick. There you go. Okay, so yes, let's go and do a TLDR. So we let's go to first on the backend side, which is the most interesting part, in my opinion. So we're using 3 different models here. One for transforming the speech into text. For that, we're using Whisper, and we're using OpenAI SDK. We are doing a transcription of our audio. We're using toFile method from OpenAI to create this file-like object, and we're sending that to our body here. Whisper is gonna be your model that is gonna understand this audio, and it's gonna do the transcription for us. And that transcription, which is gonna return a text, it can return different stuff. It can actually return a JSON or whatever. And we can send that text as a prompt in our Llama model that, again, is running locally in our machine in here, not here, but here. And we specify the model. This is the model that I downloaded, but you could download any other model, like Feed 3, for example, which is also really popular. So Llama is going to run in our server, and it's going to understand this text, and it's going to give us a response back. I give it this kind of description to it that it knows a lot about video games, and if you ask something about video games, it should sound confident about it. Then when we get the response, we get that text, and we use the theory model, which is TTS from OpenAI one more time, and we create a voice response, an audio response that we are streaming back to the user in this endpoint. So on the client side, what we are doing is that we are using 3 different APIs here. We are using the MediaRecorder API from the browser, which tells us the information about the environment of the browser of the user. So in this case, we can know if they have media devices, and if they have, we can create a stream from the audio. And if we use our MediaRecorder API, which is an API from the client side that help us to record audio or video, and we send the stream, we can start recording from the media device of the user. In this case, it's going to be my mic, or it could be your webcam if you're using a video. But in this case, it's going to be a video, an audio. So we start that, and when this is running, we are getting all those chunks of data. So we are gonna talk, right, and we're gonna send to this stream data chunks, and those chunks we're gonna store them in this reference, which is called audio chunks. Well, you can name it as you wish, but I call it that way. And here we're gonna have an array of audio blobs of chunk data, which should be blob events. So we get that, and we transform it into a single blob, a blob object, and we specify that it's going to be an audio WAV. I think we could also change this to MP3, for example, and that will be fine. Any type that the model accepts should be fine. So we transform that into blob, and then we call, before we go to a boil or whatever here, and we then call our endpoint with it. So we get our audio blob, we transform it into a base64, we send it to the endpoint, and we receive back the audio, right? Thanks to the TTS model. Then we use our audio context to store this audio and to then play it to the user. So we instantiate that, and we also create a reader to read the data that is streaming back to us. And we do all these to get the chunks. We get the chunks into a single array, and finally, after so much, we start playing the audio in the destination that the audio context gives us. So that's about
Boom. Done. Well, amazing. So is there going to be a blog post on this soon?
Oh, you're lagging one more time. I couldn't hear you. I'm sorry.
Oh, that's okay. Is there going to be a blog post on this at some point in time? Or I know we we're going to be able to post this code. So we'll post it with
Yes.
the JS drop and everything like that.
Yes, we're gonna post this in our GitHub repositories. It's gonna be open source. You can play with it. And our idea is to keep playing with it, keep enhancing it. Right now, OpenAI is running on the server, Whisper is running on the server, TTS is running on the server, but we want to make everything running locally as we are doing with Llama. We didn't have the time to do this in this record session, but that's the plan for the future.
Cool. Thank you everyone for listening, and thank you so much, Jesus, for running us through this, and we'll see you all next time.
Thank you for having me.